Let's look at these three properties with exponents. So whenever you take two exponents with the same base but different exponents, basically the formula for that is you keep the a, keep the base of a, but with these exponents you just subtract them. You'll see it pop up later on in some problems. So simply, when they have the same base, you subtract the exponents. Next, whenever you have a fraction of some sort to a power, what you do is that power distributes to each piece. So it'll simply be a to the nth over b to the nth. And then lastly, whenever you have a negative power, that distributes to each, which then flips, because negatives flip. So basically what this ends up being is b to the nth over a to the nth, because the n distributes, but the negative flips it. So when you distribute it, you get a to the negative nth and b to the negative nth, but then the negatives flip them. So it kind of did two steps in one. All right, let's look at number one. Number one here, when we look at that, it looks a lot like this one right here. So what we do is we simply, same base, so the 4 stays, and we just take the 5 and the 3 and subtract them. Surprisingly enough, 5 minus 3 is 2. It's pretty simple. So you end up with 4 squared, which ends up in this situation being 16. Now, that's the shortcut. What's technically happening here is 4 to the 5th is this. This is technically what's happening. 4 to the 5th is 4 times 4 times 4 times 4. Oops, 5 of them. And 4 to the 3rd is 4 times 4 times 4. That's what's happening. And then what you should see is 4 over 4 cancels, and then 4 over 4 cancels, and 4 over 4 cancels, leaving you with 4 times 4, which is 16. So if you ever forget, what do I do with the powers? Well, you can always write it out the long way and do some canceling and get your answer that way. Or you can just subtract the powers. I think subtracting powers is quicker and easier. Okay, number 2. Same idea, except we're going to do each piece individually. So the first thing we're going to do is look right here. Look at 5 over 20. Look at the numbers here. You just reduce that fraction. 5 over 20 ends up being, what goes into 5 and 20? 5. That would leave you 1. Out of 1, 5 goes into 5 once. 5 goes into 24. So that's the first piece. Okay, next. Focus in on this. Alright, same base, because they're both a's. So this is going to be a to the 4 minus 4, which ends up being something you'll see in a second. And then here, we're going to focus in on this. That's the first power. So I'm going to have c to the 1 minus 3. Okay, next. So we focused on the fractions, and then the a's, and then the c's. So 1/4 is 1/4. And then next, what you'll see here is, so that's still 1/4, but 4 minus 4 is 0, and 1 minus 3 is -2. Okay, getting close. Okay, 1/4 still stays, so we still have 1/4. A to the 0, well, that's 1. So doesn't that just disappear? Okay, you don't really need to multiply by 1. And then c squared. Well, doesn't that -2 mean it's going to drop to the bottom with this 4 down here? So you have 1/4. This becomes a 1, which disappears when you multiply. And c to the -2nd drops it to the bottom. There's your answer. All right, this one relates back to this formula. Whenever you have something to a power, you get this third power is going to go to each piece. So it's going to look like this. 5a to the 4th to the 3rd over ac to the 7th to the 3rd. And then that ends up giving you, well, you're going to third power both these. So 5 to the 3rd, which might be tough for some of you, but it's 125. And then a to the 4th to the 3rd, you multiply those. That's going to be a to the 12th. And then here, you're going to take this third power, take it to both pieces. So a to the 3rd. And then 7 times 3 is 21. So it's c to the 21. we can still simplify. This right here can actually still simplify. That actually leaves us with the 125 stays on top. 12 minus 3. And the c to the 21st stays. Because remember, you subtract these. Okie dokie, one more step it looks like. The 125 still sticks around. 12 minus 3 looks like it's going to be 9. Oops, sorry. That's going to be a to the 9th. Forget that. And then that's going to be c to the 21st. That looks like your answer right there. Alrighty. Technically, just real quick, just for purposes of understanding, what this is technically doing is the third power means I'm going to write it 3 times. Takes a while to write this. See, this value to the third power means write it 3 times. Now if you watch this, 5 times 5 times 5 is 125. A to the 4th, A to the 4th, A to the 4th. It was right there, A to the 12th. A is A to the 3rd. And C to the 7th, C to the 7th, C to the 7th to C21. So this right here is what's happening to get to this green. Then you have to be able to simplify it down a little bit more. Number 4. This relates to this formula right here. So what's going to happen here is this negative basically means to flip this. So the first thing you're going to do, actually let's first distribute the negative 2. And 30 to the negative 2nd power. Then the negatives flip everything. So that's going to leave me with 30 squared over negative 5 squared. So again, negative powers, we put this to the bottom and this to the top because the negative powers. And that ends up being basically, 30 squared, I'll just tell you, is 900, and negative 5 squared is 25. And you probably could leave it like that, but this actually will reduce, just so you know. If you take 900 divided by 25, that goes in, looks like 3 times. That leaves you with 15. And 25 goes in 150, looks like 6 times. So it looks like my answer is 36. Now technically this would probably work just as well. Again, when there's a negative power here, we could have done the shortcut and just flipped it right away and jumped right to here. That works. I could have skipped the blue, but whichever way works best for you.